Hey everybody. Today's lesson is on how to identify igneous rocks. We're going to spend a lot of time interpreting this chart called the Scheme for Igneous Rock Identification. So I included this chart in your Google Classroom assignment, so you should bring this up and pay attention to it as you watch this video. So at first glance, this chart seems a little overwhelming. There's a lot of new terms. There's a bunch of different mineral names and percentages, and it's just a lot going on. So what we're going to do is break this chart down into two halves. The top half, which shows you the environment of formation, and then the bottom half, which shows you the composition. So let's first look at the top half. So the top half of this chart, it says environment of formation all the way on the left side. Okay, so right here, environment of formation. And it's actually broken down into two types of environments. And this line splits the two types. So I'm going to go all the way across. So the bottom one says intrusive, and then the top says extrusive. And we're going to break these words down and define them and explain what they mean. So let's take the first word, intrusive. And we're going to fill this chart in. So an intrusive rock has the prefix in. So this means this is an igneous rock that formed inside of Earth. So that means it formed from magma. Since there's magma and lava, you can have rocks cooling from magma, or you can have rocks cooling from lava. Well, if it cooled from the magma, that means it was inside the Earth, hence the in prefix, so we call it intrusive. And in parentheses there where it says plutonic, where my cursor's on, that also means intrusive. All right? So a pluton is deep underground. So intrusive is an igneous rock that forms from magma underground. Therefore, extrusive has the prefix ex, like exiting, or exterior. So that means the volcano had to erupt. And they give you that little clue right here in parentheses. It says volcanic. So an extrusive rock formed on the surface after a volcano erupt. So an igneous rock that forms from lava on the surface. All right. Now it's actually very easy to tell an intrusive rock from an extrusive rock. We follow a simple rule. If you can see the crystals with your eyes, that means the crystals are fairly large. So we classify that rock as intrusive. If you can't see the crystals without the help of a magnifying glass or microscope, that means that rock is extrusive. Now, instead of saying large crystals, we use the term coarse. So what we're going to look at now in this part of the chart is this box on the right. Okay. So this box is going over the texture of the rock. Now, usually when you hear the word texture, you think of smooth or rough. But for rocks, we're really talking about the size of the crystals. See, it says crystal size. So if the crystals are large, we say they're coarse. If they're extremely large, then we say very coarse. Okay? So a coarse-grained rock, let me just flip back to the mouse. A coarse-grained rock means large crystals, and it's evidence of slow cooling magma. All right? So as long as the crystals are large enough to be seen by the naked eye, that means that rock formed deep underground. The reason we believe that is because that means the magma had time to cool, which means the crystals had time to grow. Therefore, they're going to be large. All right? Now, if they're too small to see, that means the lava cooled very quickly. And we refer to this as fine-grained. So fine-grained has very small crystals, and it's evidence of fast cooling. So that means it's extrusive. Now there's two other textures that can be found from this chart. Right here is called vesicular. In parentheses, it's telling you what vesicular means. So it means gas pockets. So if you found a rock with lots of trapped gases, we refer to that as a vesicular texture. That rock is strong evidence of a volcanic eruption, because in order for a rock to have lots of trapped air pockets means that the lava had to bubble. And what would make the lava bubble is a release of pressure. Think of it like a soda bottle. When you first open the top, the soda will start to bubble because you're releasing the pressure and the gases can escape. The same thing actually happens during a volcanic eruption. If the volcano is going to erupt, the pressure from within is allowed to escape, so the gases that are inside the magma start to come out. And the magma or lava start to bubble, and as it bubbles, it freezes or solidifies, and you get a rock that has lots of trapped gas pockets. We call this a vesicular texture. So if you find it, it has to be extrusive, all right? And it has gas pockets. All right, the last kind of texture we find with igneous rocks, we've discussed a little bit with minerals. It's called glassy. Now, if you remember, I said glass is not a mineral because glass does not have what's called the crystal structure. And they're telling you that right here. It says glass, and right next to glass, it says non-crystalline. Non-crystalline, not crystals. So you can get some definitions from this chart directly or indirectly if you know how to read it. So glass actually forms from the most rapid cooling lava. The lava cools so fast, there's no time for a pattern to form in the atoms, which means there's no crystal structure. All right, so glass. Wait for this sidebar to leave so you can read it. So glassy, it says glassy under here, is an igneous rock that forms from the most rapid cooling lava. All right, let me clear this page so I can write on it again. All right, now we're going to look at the bottom half of the graph. And this graph goes over the composition. All right, and the way you read this is it gives you some information right here in the middle. So let's start with composition. So you have two types. If I look all the way to the left, it says felsic. And if I look all the way to the right, it says mafic. So there's really two major kinds of chemical composition for igneous rock. We either classify it as felsic or mafic. And felsic, the definition is right here. So a felsic rock, well, what word is above it? Is a lower density, and that says lighter color. So felsic is a lower density, light colored igneous rock. And then let's see what's written in parentheses here. Rich in silicon and aluminum. So just by reading the chart, it gives you the definition of felsic. All right. I actually did mafic first, so let me go over mafic as well. So the definition of mafic then, all right. So I circled mafic right there on the right. So mafic has a higher density, darker color. All right. So the definition of mafic is a high density, dark colored rock rich in iron and magnesium. And actually, mafic is a made up word. They took magnesium, that's the MA, mafic, I guess is how you really pronounce it, And iron is a ferric. That's why it's Fe in the periodic table. So they just combined magnesium ferric, and they invented a new word called mafic or mafic. All right. And that's what gives it its dark color. So unlike minerals, which you should never judge by color, for rocks, igneous rocks especially, you can. So if you found a dark igneous rock, you would say that rock is mafic. All right. Now, if you find a light colored igneous rock, we refer to that as felsic. So the definition of a felsic rock is a low density, light colored rock rich in silicon and aluminum. And felsic is also a made up word. They took feldspar, because there's a lot of feldspar, is a very common mineral. See potassium feldspar here, plagioclase feldspar. And then all the rest of these minerals that are in this rock are what's called silicates. So basically, they took feldspar and silicates and made up the word felsic. So they're made up of feldspars and other silicates, right? Or silica, which is another word for quartz sometimes. All right. Now, I'm going to teach you how to read these minerals and in the actual chart as well. But we're going to use both parts together now. Okay. We're going to use both of these graphs together. So normally we would have a lab. And in the lab, you would get a bunch of different rocks. And then you would have this scheme and try to figure out the rock's name. So basically, we're going to do the lab, but virtually. So let's imagine this is the first rock you got. All right. So you pick up the rock and you make 2 observations is really all you need to do. First observation, can you see the crystals with your eyes? So do you see lots of different colors there? And the answer is yes. That means you would classify this as intrusive. Because the general rule of thumb is if you can see the crystals with your eyes, it formed on the ground. Okay? Now you have to figure out if this is light colored or dark color. The rule is if there's any pink to like an orange kind of color in it, see it says pink right here? That means it's light in color. So we are looking at a felsic rock. So we are looking at a felsic rock that has large crystals, which means it's one of these 2, granite or a pegmatite. All right, pegmatite, the crystals would be bigger than my thumb. All right, so this is not a pegmatite. Pegmatite is where you would want to go mine for like big rubies and other gems. You would go to a pegmatite mine. So this is granite. So a lot of you might have gotten that without even learning anything about rocks yet, because you might have granite counters in your house. Okay? All right, so that's the first rock we're going to look at, and you would have classified it as granite. And the reason why is it's light in color. That makes it felsic, so you go to the left, so which means it's one of these minerals to the left of that line. And since you can see the crystals, it has to then be below that line. All right? All right, so now we're going to look at another one. So let's say this is the second rock you get. Well, this looks like it's half black and half white. So we say the general rule for a rock like this, if the rock kind of looks like salt and pepper, that means it's not all the way on the left and it's not all the way on the right. It falls in the middle, kind of has an intermediate composition. So it's one of those rocks between those pink lines. Now, can you see the crystals? The answer is yes. So that means it's coarse. So this rock is diorite. Okay? That is diorite. All right. Next. Okay, so here is a rock that's pretty much all black, got some white to gray in there, but really almost all black. So I would definitely classify this as dark. Therefore, if it's dark, it's mafic. So the rock is going to be classified on the right. Now, for really dark rocks, you really have to pick them up and move them around to see the shine of the minerals. So I'm just going to tell you that this is coarse. So with the information you know, I would accept any one of these answers, gabbro, peridotite, or dunite, because you don't have enough information. So you would be marked correct on a lab. I'm just telling you that this is gabbro, all right? Now, if you look below at the minerals present, you might be confused because there should be a lot of greens. The green is so dark, it's going to appear black to our eyes, all right? So I just wanted to mention that. Okay. Now, while I'm on the topic, the ones that are all the way on the right, those two, we sometimes refer to their composition as ultramafic. Okay. And the ones in the middle, we sometimes refer to that as andesitic. Okay? And it has the word Andes. And that actually comes from the Andes Mountains. I don't know which was named first, the rock or the mountain range. All right. And sometimes instead of saying felsic, we say granitic, having the characteristics of granite. So we say granitic, andesitic for the middle, and sometimes instead of saying mafic, we sometimes just describe it as basaltic. And we're going to look at some of those now as well. So here's all three together, so you can really see the color change. So the one on the left, we show you how to use what's below it. So the pinks are your potassium feldspar. The whites are your quartz. The gray here is your plagioclase feldspar. And then the different black minerals, there's two black minerals. One's called biotite mica, and the other's called amphibole, specifically an amphibole called hornblende. Okay. Now, as you go to the right, look what happens to the pinks. They get squeezed out. So by the time you get to this zone here, all the pinks are gone. Like imagine this rock and the pinks disappear. You'll get this rock. But then as the whites disappear, you're kind of left with that. All right? So what determines this composition is the composition of the magma. So magma that has more silicon and aluminum will be lighter colored. Magma that has more iron and magnesium will be darker colored. And the darker magma makes up the seafloor. So these kind of rocks make up the ocean. And these kind of rocks make up the continents. And these make up the coastline between the oceans and the continents. All right? All right. Next is going to be extrusive rocks. Oh, no, sorry. Same picture. So granite to diorite to gabbro. Just another way of looking at the same thing I just gave you. And here is just more information. This is what I just did with the granite, except more of a close-up. So it's showing you the quartz. It's showing you the two black minerals. It's showing you the pink feldspar, also known as potassium feldspar or orthoclase, and then the white to gray feldspar known as plagioclase. So they're giving you close-up of these minerals. All right, extrusive rocks. So let's say you get this rock in lab. Now you can't see the crystals here. So the fact that I can't see these crystals, I'm going to call this, extrusive. Now I don't see gas pockets, and it doesn't look like glass, so this is going to be classified as fine. Now, is this dark or light in color? The rule is if there's any pink, it's light in color. Well, this is a real pale pink, so this is a light colored All right, so this is fine. So it's a fine-grained rock that's light in color. I don't see any gas pockets, so this is rhyolite. Okay? Next rock. So this is a pale gray to white, a little very light gray. Okay, so it's not too dark, but it's not light either. I don't see any gas pockets again, so I would classify this as fine. So it's one of these. All right. And it's not too dark, it's not too light, so it's in the middle. So this is andesite. This is the one that makes up the Andes Mountains. Okay. Next up is this black kind of featureless rock. No gas pockets. It doesn't look like it has glass. So once again, this is fine. And since it's black, it's on the right, which makes it mafic. So it's one of these rocks on the right. That is fine. I don't see gas pockets, so it's not vesicular. So this is basalt. And this is the rock that makes up the seafloor. All right. Okay, so this is going to show you all of them together. So you really see this is light, in the middle, dark. Felsic, intermediate, mafic. And this is really the same exact thing again, just showing you all three. Little different varieties of those three rocks. All right, now let's look at some vesicular rocks. So here's a real light colored rock. So the fact that it's light colored, it is felsic, which means it has to be in here. And you see all those little holes? Those are gas pockets, which means it's vesicular. All right. So in lab, if you said vesicular rhyolite, I wouldn't mark you wrong. Some of you might have this rock in your homes or seen it possibly in like beauty salons. It's used for, manicures and pedicures sometimes. This is called pumice stone. All right. So pumice is a vesicular rock that is felsic. All right. And then the next one. So here's a black rock with lots of holes. So the fact that it's black, it's going to fall under the mafic category. But since there's holes, it's vesicular. So I would accept either scoria or vesicular basalt based on these observations. Scoria is more of a dark red. So this is probably vesicular basalt, which is more black. Okay. All right, I'm going to end with one last rock. This is obsidian. So a lot of people come in with knowledge of obsidian, maybe from Minecraft. I know my kids do. But you might have learned about it in history because it was made to make arrows and spears for ancient cultures, since it would break and have these sharp edges. But the reason I want to spend some time on it is you can kind of see the glassy surface. So this is volcanic glass, but this kind of doesn't fit in with the classification because this is black, yet it's felsic. See, obsidian is on the left side. So it's glassy. And then it says under obsidian, usually, I just crossed it out, usually appears black. All right. It can actually be clear in thin sections. All right. It's just opaque when it's a big chunk, so light can't get through. So it appears black, but there's so much silicon in there, it is definitely felsic. All right. That's it for today. I hope you learned about igneous rocks. As always, subscribe to my page, like me, and ask me questions through email or at the Google Meet sessions. All right? Have a great day.